Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to YouTube channel Chandan Physics. In this video, we are going to discuss Compton effect. Let's begin. In the year 1921, the scientist A.S. Compton discovered that when a beam of monochromatic radiation, that the monochromatic radiation is with high frequency or low wavelength. As we relate, wavelength is inversely proportional to that of frequency. That's why if we consider high frequency, in that manner we call it as low wavelength. So the radiations under high frequency or low wavelength are X-rays or gamma rays is allowed to fall on a substance, then that scattered radiation we notice having greater wavelength, which is called Compton effect. When monochromatic radiation is incident on a substance and that scattering radiation we obtained having greater in wavelength. So that a change in wavelength, incident monochromatic radiation wavelength, scattered monochromatic radiation wavelength, there will be a change. So that a change in wavelength is called Compton shift. Let me understand it. Monochromatic radiation is incident on a substance. Here we taken that radiation in the form of X-rays or gamma rays. X-rays and or gamma rays are high frequency or low wavelength type of radiations. In that of substance, we choose free electrons. In that of substance, we choose free electron. That electron is at rest. Electron is at rest, and that one is a free type electron. Practically that is not an individual electron, that is a substance. In that of substance, that is an atom, and in that of atom we prefer a free electron. So X-rays are incident on that of substance. According to classical theory fails to explain such type of Compton effect. But Compton used quantum theory in order to solve that difficulty. That difficulty happened in case of classical theory. Since X-rays are incident on that of substance, X-rays are nothing but photons. So photon is incident, that is the incident photon. And that incident photon having the energy Planck's constant into frequency, and its momentum that is energy divided by speed of light, that is h nu divided by c. So when incident photon to that of rest electron x axis, y axis. Show that the photon is scattered, that photon is scattered by an angle theta to that of x axis. That angle theta is called scattering angle, scattering angle, and that electron recoil, which is called recoil electron, recoil electron, and that angle of recoil is called phi, angle of recoil. This one is the scattered photon, scattered photon. So, when incident photon to that of electron, so it is scattered and that electron recoil. That scattered photon to an angle, scattering angle theta, recoil electron at an angle of recoil phi. That scattered angle, sorry, that scattered photon having change in energy. So, that the energy of scattered photon, as you notice here, energy is nu dash with the frequency after that scattering. Similarly, momentum is equal to S nu dash divided by C, and that momentum now resolute in that two components along x axis and y axis. Here we resolute that momentum, the scattering angle as theta, momentum h nu dash by c. So, along x axis it is h nu dash by c cos theta, along y axis it is h nu dash by c sin theta. Then for that of recoil electron, it has the energy is equal to mc square, m be the mass of an electron. Similarly, momentum for that of electron as mass into velocity. Let v be the velocity of electron. Write m mass of electron, v velocity of electron. Again, that recoil electron at an angle phi, show that the momentum now resolute into two components, one along x axis, another along y axis. That be the angle phi. Along x axis it is mv cos phi, along y axis it is mv sin phi. Now, mathematically we showcase what be the change in wavelength, means the Compton shift. Here we use law of conservation of energy and law of conservation of momentum. Law of conservation of energy and law of conservation of momentum before collision and after collision. Applying law of conservation of energy before and after collision. First, applying law of conservation of energy. So, energy of the system before collision is equal to energy of the system after collision. First, energy of the system before collision. Before collision, when electron and the incident photon are not collide with each other, then the energy of photon S nu and energy of electron m naught c square. This is the energy of photon plus energy of electron m naught with the rest mass of that electron. M naught rest mass of electron, and that value m divided by 1 minus v square by c square under root. So, energy of the system before collision, that is energy of photon plus energy of electron, is equal to energy of the system after collision. After collide, this is the scattered photon, that is the recoil electron. So, the energy of such photon as S nu dash, S nu dash. Next, energy of that electron mc square, energy of that of electron mc square. Now, the energy of the system before collision S nu plus m naught c square, which is equal to energy of the system after collision S nu dash plus mc square according to the law of conservation of energy. Then we apply law of conservation of momentum. As we resolute that momentum along x axis and y axis, so along x axis it is calculated and along y axis it is calculated, and finally we add these two. First, along x axis, along x axis, look here, along x axis the momentum for that of photon S nu by c, and for that of electron there will be no such momentum. So, along x axis for photon S nu by c plus electron no momentum, as electron at 0 at rest. So, the momentum is 0 here. Next, after collision along x axis for photon it is S nu dash by c cos theta, for electron it is mv cos phi, S nu dash by c cos theta plus mv cos phi. Now, simplifying it, S nu as that c taking LCM and it is multiplied here, and the c cancelled out on both sides. S nu is equal to S nu dash cos theta plus mv c cos phi, then mv c cos phi is equal to S nu minus S nu dash cos theta, equation 2. Similarly, along y axis for that of incident photon there will be no component along y axis. Similarly, we write it as for photon the momentum along y axis 0, for electron the momentum along y axis 0 before collision, and after collision for photon along y axis that is S nu dash by c sin theta, S nu dash by c sin theta. For electron along y axis that is mv sin phi, and its direction is just opposite. We use negative sign mv sin phi. Simplifying it, we obtain mvc sin phi is equal to s nu dash sin theta. Now, for resultant, we calculating as a squaring and adding these two equations, squaring and adding equation 2 and equation number 3. First we square equation number 2, then equation number 3, and add these two equations, squaring and adding. M square, b square, c square as common. Inside that bracket we have sin square phi plus cos square phi. Here a minus b whole square formula is used, a square plus b square minus 2ab, a square b square minus 2ab. Sin square phi plus cos square phi is equal to 1. In that term, h square nu dash square as common. Inside that bracket sin square theta plus cos square theta as usual terms. Then sin square theta plus cos square theta is equal to 1. Next terms are written. Here we taken h square as common. Inside that bracket term, we write it in that order as h square plus nu square plus nu dash square minus 2 nu dash cos theta. Equation number 4. Next, from that of equation number 1, we find out the value of mc square. From that of equation number 1, s nu dash plus mc square is equal to h nu plus m naught c square. Here we can easily calculate the value of mc square, then squaring on both sides and using the formula a minus b whole square here. So that equation change to this one. Now we can subtract that equation number 6 from equation number 4, that is m square c fourth minus m square b square c square. Then that term as subtracted from this term. M square c square is common. Inside that bracket c square minus b square. Here this term and this term, look here, the terms h square nu square minus h square nu square, h square nu dash square minus h square nu dash square cancelled out. The term exists here as 2h square nu minus nu dash. So inside that bracket 1 minus cos theta. Next term 2s nu minus nu dash m naught c square, last term m naught square c fourth. C square taken common, so the bracket term will be 1 minus b square by c square. C square is common, that term as m square c to the power fourth. As usual terms are written. Now we can use the value of mass of electron is equal to rest mass divided by 1 minus b square by c square under root, as I write it here. So that equation value for m is substituted. So this that cancelled out. Then the equations simplified. In this m naught square c fourth, m naught square c fourth cancelled out, that minus to this side as plus, then 2s cancelled out, and that nu dash divided on this side. So nu minus nu dash divided by nu dash is equal to s divided by m naught c square 1 minus cos theta. Individual terms, nu divided by nu dash minus nu dash divided by nu dash. 1 nu cancelled out, so 1 by nu dash is equal to 1 by nu. That so the relation in between frequency and wavelength, that frequency and wavelength relation to be used. Therefore we multiply c on both sides. C is multiplied here, c by nu dash as lambda dash, c by nu as lambda. Then that term lambda dash minus lambda is equal to delta lambda is equal to that term as lambda naught 1 minus cos theta. So lambda dash by lambda, that is the change in wavelength, which is called Compton shift, and that value S by m naught c is called Compton wavelength. Look that expression, that Compton shift depend only upon that angle theta, but it is independent of the nature of what be the scatterer we use. It is Compton shift depends only on angle of scattering. It is independent of the nature of scatterer. Depend upon angle of scattering, independent of nature of scatterer. So that equation we derived, this is the change in wavelength. As we notice here, incident photon, scattered photon have increase in wavelength. So what be the increment? That increment we notice in that particular equation. That phenomenon is called Compton effect, and we can theoretically prove it by taking the quantum theory as proposed by Compton. Compton used quantum theory to prove such phenomenon. Next, here we notice the recoil electron. So what be the direction of such recoil electron and the kinetic energy of that recoil electron? To derive the direction of that of recoil electron, that is nothing but the relation between angle of recoil and angle of scattering. So what be the angle of recoil? Phi, angle of scattering theta. How these two are related? Come to equation number 2 and equation number 3, as we prefer for that of momentum along x axis and y axis. Now dividing these two equations, dividing 3 by 2, MVC cancel out, sin phi by cos phi, tan phi. In that section, h as common from numerator and denominator cancelled out. Finally, we obtain tan phi is equal to nu dash sin theta divided by nu minus nu dash cos theta. Now, from equation number A, we point out that as equation number A, in order to calculate the value of nu dash in terms of this, from that equation 1 by nu dash 1 minus cos theta, trigonometry formula is used, 2 sin square theta by 2, taking the LCM as nu. So nu dash is equal to, now change, so nu divided by that term. So value of nu dash is putted in that of equation number 8. In place of nu dash we substitute that value. In place of nu dash we substitute that value. In that of numerator and denominator, that term and this term both are cancelled. So the reduced term nu sin theta divided by, here as we taken that LCM, so nu as common, and this in these two terms nu as common and nu cancelled out. Finally, we obtain that equation, and we simplified it in this manner: 1 plus 1 minus cos theta, again another terms as h nu m naught c square 2 sin square theta by 2. Here 1 minus cos theta, again use the trigonometric formula 2 sin square theta by 2. In these two terms 2 sin square theta by 2 as common, and again in place of sin theta we substitute 2 sin theta by 2 into cos theta by 2, sin square theta by 2 sin theta by 2, 1 sin theta by 2 cancelled out, 2 to cancel out, cos theta by 2 divided by that one, cos by sin, that is cot. So cot theta by 2 is equal to this. This is the relation in between phi and theta. This is the required relation. This is the required relation between angle of scattering, angle of recoil and angle of scattering. The required relation, angle of scattering and angle of recoil, phi and theta. Simple mathematics. Next, what will be the kinetic energy possessed by such recoil electron? Come to that figure. The energy of incident photon now used in what purposes? To the energy of scattered photon and the energy of that of recoil electron. So that incident photon energy, this is the energy of scattered photon. So what will be the change in energy? That is nothing but the kinetic energy possessed by that of recoil electron as energy used in scattered plus recoil electron. So what will be the change in energy? It's nothing but the kinetic energy possessed by that of recoil electron. So the kinetic energy of such recoil electron, the kinetic energy of recoil electron is equal to the decrease in energy in that of incident photon. So the kinetic energy of recoil electron is equal to, here the incident energy h nu minus the scattered photon energy h nu dash. So h as common, nu minus nu dash, h nu as common, 1 minus nu dash by nu, using the relation nu is equal to c by lambda. So in place of nu we substitute c by lambda. So c by lambda dash divided by c by lambda dash. Here c cancel out, and in that of bracket term it will be 1 minus lambda by lambda dash. Next, taking the LCM, so lambda dash by lambda divided by lambda dash minus lambda divided by lambda dash, that is the change in wavelength, which is nothing but delta lambda, which is called Compton shift, and lambda dash is equal to lambda plus del lambda. The substitution is used here. In place of lambda dash minus lambda, that is del lambda, and in place of lambda dash, that is lambda plus del lambda. So the value of Compton shift, as we derived, h by m naught c 1 minus cos theta in that of equation, that is Compton shift. Here lambda naught as h minus m naught c, that is the Compton wavelength. That value of delta lambda is used, and simplifying it, here we use in place of in that of numerator lambda is multiplied, in that of lambda is divide, here lambda is divide, that lambda is cancelled due to division of such lambda, and using that relation lambda is equal to c by nu. Then finally we obtain E is equal to that one, the kinetic energy of such recoil electron. This is the relation, this is the equation of kinetic energy of recoil electron. It depends upon the scattering angle. It depends on the scattering angle. So here with the help of this video lecture we understand Compton effect. What is Compton effect and Compton shift, and that can be proved by using quantum theory, as we prefer incident photon to that of rest electron, scattered photon, recoil electron, and such scenario. applying the conservation of inertia and momentum before and after collision. First, conservation of inertia before collision is equal to after collision. Next, conservation of momentum along x axis and along y axis, then combine these two. From equation number 1 we simplified it and subtracting from that of equation number 6, and finally we obtain the expression for Compton shift, that is the change in wavelength, and what the value of Compton wavelength. From that of equation it is clear that Compton shift depends only on that scattering angle. What be the angle of scattering, that decide what be the change in that wavelength or the Compton shift, that does not depend upon what be the scatterer. It is independent of the nature of scatterer. Next, the direction of such recoil electron, that is the relation between angle of recoil and angle of scattering, simple mathematics, and the relation between phi and theta. Kinetic energy of recoil electron, which is equal to the decrease in energy for that of incident photon. Mathematically we showcase that expression, and it is clear that it depends on that scattering angle, theta with the scattering angle. So, with this useful and informative notes, let me wind up the session. Thank you.